Hi guys, Dr. Diaz here again. Okay, you remember the two previous videos that I did? The one has to do with concave mirrors. Okay, if you remember the case, I think I call it case A, is the one in which the object is far away from the center of curvature beyond. So here is actually a nice picture of what exactly is happening in how the image is formed. Look at this one. Remember, this is B is the object. Here B is the object. This is the object. And from the object, a ray that it goes parallel to the optical axis. When it hit the mirror, it will go to the focus and keep going all the way. And then here they trace another ray. The other ray that I would trace will be one that it goes to the focus. When it hit here, it will converge and it will go parallel to the optical axis. The ray that they're tracing is one that it goes straight through the center of curvature, and that one will bounce back because you don't remember the center of curvature is sort of a center of a circle. It will bounce back. And where those rays, and actually you can throw the third ray, which usually is the one that I say you use, right? The one that it goes from the object to the focus to the mirror, and it bounces back parallel to the optical axis. You see, I can write it. It will go something like this, and it will go back, and all three rays are gonna converge at the same point. And in this point, when those three rays converge, there's the image form, which in this case is gonna be what? Small, downward, or inverted, that they call it here, and real. Look at this case. This case here is similar to the last problem we did. In which the object now is at the center of curvature. And here we go. A ray that it goes parallel to the optical axis. When it hit the mirror, it will go all the way across to the focus. They, instead of actually they did. Then a ray that it goes through the focus, when it hit the mirror, it will go parallel to the optical axis. And voila, where this rays intersect, there's where the image is formed. The image is always going to be formed from the optical axis, and here they call it principal axis. From the optical axis to where those rays converge, there's the image. And in this case, like I said, when the object is in the center of curvature, the image is going to be real, downward, or inverted, like they call it here, and the same size. In my diagram, it doesn't look the same size, but yes, it is supposed to be the same size. So these are the two cases we examined in the past video. So we're going to go for our third case. Here we have the case. An object that is between the center of curvature and the focus. And we're going to do exactly the same thing. Ray tracing. The first ray, a ray that it goes parallel to the optical axis. When it hit the mirror, it will go to the focus. Then we would throw one that it goes to the focus, and it goes to the parallel to the optical axis. And where those two rays converge, that's where the image is going to be formed. There's another third ray we can throw, but actually that's a little bit difficult because this is very difficult. So usually you can throw three rays, like in that example I'll show you a moment ago. But in this case, it's better to do the parallel one that it goes from the tip of the image, goes parallel to the optical axis, hit the mirror, and it goes through the focus. And the other one, it goes through the focus, and then later, after bouncing off, the mirror is going parallel to the optical axis. Draw the rays here. And here we have it. A ray that it goes parallel to the optical axis. When it hit the mirror, it will bounce back and go to the focus. Now, let's throw the one that it goes through the focus and see what's going to happen. Here we have it. Remember, a ray that it goes parallel to the optical axis from the object and hit the mirror, it will go to the focus. Oh, there. That's okay. All the way to infinite. The one that it goes from the object through the focus, when it hit the mirror, it will bounce back parallel to the optical axis. And where these two rays intersect, here was where the image is formed. And now you can see the characteristics of the image here. Characteristics. Well, you see first that is real. It's a real image. Second, that is inverted or downward. Let's put inverted since so that word a moment ago. And third is bigger than the object. Bigger than the object. Yes, it is. Let's do another case, but let me see if I can find another video or image that can show you this perfectly. And here it is. Here's the image I was looking for. Look, the object is between the center curvature and the focus. A ray that goes parallel to the optical axis. When it hits the mirror, it goes to the focus and all the way to infinity. The one that it goes from the focus, when it hits the mirror, goes parallel to the optical axis, and like we did when those two converge, that's where the image is formed. Always the image going from the optical axis to where the point, where those two lines converge. And you can see that is bigger or large, real, and inverted. Now let's do another case. Now, okay guys, now let's analyze the case in which the object is actually at the focus. Here. And as usual, we're going to do the same thing. A ray that it goes parallel to the optical axis, when it hit the mirror, it will go through the focus. So let's trace that one. So we have a ray that it goes parallel to the optical axis. When it hit the mirror, it will bounce back and it will go through the focus. Let's assume that it's actually going through the focus, because I struggle a little bit doing this one. Now we need one that it goes through the focus, but we cannot write that one because that one is through the focus, right? It's in the focus. We cannot draw that one. But there's another ray that we can draw, which I don't use it that much, but in this case it could be. And it's one that it says a ray that it goes from the object exactly at the center of the optical axis here, the center here. When it bounces back, it will go in this direction, because then the angle that is going to form here and here, they're going to be the same, because we will be using here the law of refraction, or reflection, I'm sorry. Let's go do that one in a second. Okay, I can draw that thing nicely, but here it goes. A ray that it goes exactly to the center of the optical axis. When it bounces off, it will go in this direction. Actually, you can see these two rays are parallel. They would never intersect. That means that when the object's at the focus, no image is formed. Okay, this is actually no image is formed. Looks like a mole, but actually it's no image is formed. When the object is exactly at the center, exactly at the focus, no image is formed. And some of you have played with mirrors. You know, concave mirrors. You know that there's one point in which when you put it that close to your face, it gets bigger and then smaller. But there's one point in which the image disappears. This is the case. When you are exactly at the focus, no image is formed. When the object is exactly at the focus, no image is formed. Okay, guys, I hope this helped a little bit. Then we're going to start 2 more cases, and then we go to the convex mirror. Bye. See you next time.